Black holes are among the most fascinating objects in space, but they also happen to be among the most mysterious. Despite recent scientific innovation providing us a first look at an actual black hole far into space, we have yet to grasp any definitive information as to what lies inside it. Using quantum computing and deep learning, a team of scientists have embarked on finding out what lies within these gluttonous objects, leading to explosive learnings and more mind-boggling theories. Keep watching till the end of this video to delve deeper into what scientists discovered about black holes, because the concepts discussed here may blow your mind. Of all the objects in the known universe, there's no other region that invokes as much appeal, curiosity, and fear than black holes. Black holes are infinitely dense points in space that have the capacity of spaghettifying anything that ventures too close to it. These points in space are so dense that they create deep gravity sinks in space and time. Matter is squeezed into such a tiny space that gravity around it becomes immeasurably strong, to a point in fact that not even light can escape its powerful tug. This means that literally anything that comes too close to it, whether it's a star, a planet, or a spacecraft, will end up getting stretched, compressed, and shredded in a theoretical process known as spaghettification. There are 4 types of black holes known to science: stellar, intermediate, supermassive, and miniature black holes. In varying sizes, black holes can be big or small. Scientists believe that the smallest black holes can be as miniature as just one atom. But despite its punitive relative size, this atom-sized black hole can still have the mass of a large mountain. Larger black holes, such as the ones considered stellar black holes, can have a mass of up to 20 times more than the mass of the Sun. Meanwhile, supermassive black holes have masses that are equal to billions of suns placed together in one point of space. Scientists have also claimed proof that every large galaxy contains at least one supermassive black hole at its center, such as Sagittarius A, the supermassive black hole located at the center of our own galaxy, the Milky Way. Sagittarius A has a mass equal to 4 million suns, despite being able to fit inside a very large area that can contain a few million Earths. The smallest of black holes were formed when the universe began during the Big Bang 13.7 billion years ago, and could have possibly evaporated after some time, while stellar black holes are made when a big star collapses into a supernova. Supermassive black holes, on the other hand, are theorized to have been made at the same time as the galaxies they are located in. These black holes have the ability of growing throughout their lives, consuming gas and dust from any object in space that creep too close to it. Anything that passes its event horizon, or the point where its gravity is inescapable, is bound to turn into spaghettified matter. As matter is pulled into the black hole's center, or its point of singularity, due to the radical increase in the strength of gravity as you fall into the black hole. Scientists also believe that spinning black holes generate strong magnetic fields that are twisted by its rotation, with these strong fields acting as springs that can accelerate charged particles on an outward direction away from its center or singularity. In essence, black holes are quite invisible and hard to spot. Since no light can escape from it, it can't be seen. Its ultra-strong gravity pulls all of the light into the middle of the black hole, making it quite a challenge to locate. However, using space telescopes with special tools and techniques, scientists are able to distinguish and locate these mysterious objects in space by focusing on its strong gravity and how it can affect the stars and gas around it. The earliest process of black hole discovery was actually made by pinpointing radio waves, and was totally made by surprise. Milky Way's very own supermassive black hole, Sagittarius A, was accidentally discovered in 1933 by physicist Carl Gustav Jansky, who was tasked to determine the sources of noise that interfered with shortwave radio telephone communications at the time. This led him to design a highly directional antenna to find where the steady hiss static was coming from. This led to the surprise discovery of radio waves coming from the center of our Milky Way galaxy, which would later be identified as the supermassive black hole Sagittarius A. This detection of cosmic radio waves led to the beginning of radio astronomy. By studying nearby stars, scientists can determine if they are flying around or orbiting a nearby black hole. When a black hole and a star come into close proximity, high-energy light is emitted, which are detected using satellites and telescopes. Astronomers and scientists also use a black hole's intense gravity tugs on surrounding objects to record erratic movements that determine a black hole's presence. But while research and theory has provided us the path to determining a black hole's presence, there is still no definite interpretation as to what could possibly lie inside a black hole itself. From theories of warp holes and tears in space-time, no one truly knows what lies beyond a black hole's center. This is what a recent study aimed to perceive, to finally discover what's inside a black hole. In early February 2022, a study was published in the journal PRX Quantum which attempted to find out what could be inside of a black hole. By incorporating matrix model simulations, quantum computing, deep learning, and Euclidean lattice Monte Carlo simulations, the researchers presented an interesting theory that sounds like it could be taken straight from a science fiction movie. According to the study, black holes could simply be just holograms, and by association, the entire universe itself could be one giant hologram as well. However, before taking in the concept of everything being a simulation, take into consideration that this idea is but one part of the general theory presented in this recent study. The theory that black holes could just be holograms is claimed by the study after taking a closer look at the concept of holographic duality. Holographic duality is a mathematical conjecture that attempts to connect theories of particles and their interactions, as well as the theory of gravity. The study suggests that holographic duality proves that these two concepts, the theory of gravity and the theory of particles, are mathematically equivalent. This concept has quickly become a popular notion used to better understand black holes. According to Enrico Rinaldi, a research scientist from the University of Michigan, using these two theories could allow us to better understand what's actually inside a black hole. Rinaldi mentions, in Einstein's general relativity theory, there are no particles. There's just space-time. And in the standard model of particle physics, there's no gravity, there's just particles. Connecting the two different theories is a long-standing issue in physics, something people have been trying to do since the last century. Rinaldi and co-authors of the study used quantum matrix models to connect these two theories in order to discover new information about holographic duality in black holes. Using the matrix models, they were able to clarify what they believe the inside of a black hole looks like. Their findings suggest that when they refer to black holes as a hologram, they're pointing out the way the inside meets with the outside itself. The inside of a black hole is represented in 3D space as space-time moves through it, due to the way black holes interact with the theory of gravity. Black holes also appear two-dimensional, giving it a holographic appearance since people can't view them as a 3D object in space. They suggest that this is so due to the fact that the theory of particles can't work in 3 dimensions. In holographic duality, the theory of gravity and the theory of particles are mathematically equivalent. Therefore, whatever happens mathematically in the theory of gravity should also occur in the theory of particles. The researchers are hoping that probing this idea, despite the two theories existing in different dimensions, to provide more insight as to what could possibly be inside a black hole. By attempting to merge the theory of gravity with the theory of particles, the researchers of the study are offering a perspective at how the inside of a black hole meets with the outside. The inside of a black hole works off the theory of gravity, which is represented in 3D space as space-time moves through it. And since we can't see black holes as a 3D object, it looks two-dimensional on the surface, which also supports the theory of particles, since this theory does not work in 3 dimensions. This posits the idea that the rest of the universe may also work in a similar manner with regards to combining particles and gravity. But while these theories may seem out of this world, there is still no current proof to suggest that this is what we can expect inside a black hole. As such, we can only surmise from these theories until an actual visit to a black hole is made. So, what are your thoughts on these theories? Let us know in the comments below. Thanks for tuning into StarBurst. We hope you've enjoyed this video and learned something new about our incredible universe. Don't forget to subscribe to our channel for more exciting content and hit the notification bell so you never miss an episode.